afternoon. Today we are going to be starting our unit on ratios, proportions, and percents. Our first lesson will cover ratios. You do need to grab you a piece of paper and a pencil. You are required to take notes, work through example problems, and then you will have a few problems that you will have to complete to turn in tomorrow at the beginning of class. Remember, this is a video, so you may stop, pause, rewind, fast forward whenever you need to. So grab your materials and let's get started. I can statements. I can understand that a ratio is an ordered pair of non-negative numbers which are not both zero. I can understand that a ratio is often used instead of describing the first number as a multiple of the second. I can use the precise language and notation of ratios. I can understand that the order of the pairs of numbers in the ratio matters, and that the description of the ratio relationship determines the correct order of the numbers. I can create multiple ratios from a context in which more than two quantities are given, and I can conceive of real-world contextual situations to match a given ratio. Things you will need to include in your notes. What is ratio? What are the three ways you can represent a ratio? How do we determine which part of the ratio to represent first? What is a tape diagram? What are the verbal cues that indicate a ratio relationship? Ratios. Ratios are used to compare parts to a whole. Ratios are used to compare amounts. They can be written using a colon. Example, 1:2. Ratios do not always explain the actual amount, but rather a relationship or comparison. Ratios are written based on the order of the amount that are requested in the question. Like fractions, ratios may need to be reduced to lowest term or simplest form. Ratios can look like fractions. Example, 1/2. Numbers must be written in the order they are requested. A ratio is always a pair of numbers, such as 2:3, and never a pair of quantities, such as 2 centimeters, 3 seconds. Ratios continued. Ratios can be written three different ways. Example, the recipe for jam requires 3 cups of sugar for every 6 cups of strawberries. What is the ratio of strawberries to sugar in this recipe? Numbers must be written in the order they are requested, not in the information part of the problem, but in the question part. Therefore, in the question part of this problem, strawberries is mentioned first. The three different ways to represent this ratio are using the word 2, 6:3, using a semicolon, 6:3, or as a fraction, 6/3. Because if you look back in the informational part, it shows us that strawberries was 6 cups, and for the sugar, it was 3 cups. Alright, examples to try in your notes. A simple cake recipe: 1 cup of milk, 2 cups sugar, 3 cups flour, 4 eggs beaten. Mix thoroughly. Bake at 350 degrees Fahrenheit until done. Use the recipe above to write the ratio for each comparison. Express your answers in fraction form and simplify to lowest term. So number 1, you're doing milk to sugar. Number 2, flour to eggs. Number 3, eggs to milk. Number 4, sugar to milk. Please pause video until you have written a ratio for each example. So let's look at the answers to the example problems. For number 1, it said milk to sugar. So if I go back up in my recipe and I look and it says milk to sugar, I see that I have 1 cup of milk. And then to look at sugar, I see I have 2 cups. So I get 1/2. Flour to eggs. I see I have 3 cups of flour. Then I look at my eggs. I have 4 eggs. So it would go on the bottom. 4. Flour to eggs. Looking at number 3, eggs to milk. Eggs to milk. I look at first my eggs, which is 4 eggs. Then I look to see what my milk is, which is 1 cup of milk. So I would have 1. 4/1. And number 4, sugar to milk. So I look at how many cups of sugar, which is 2. And then my milk, I have 1 cup of milk, so I would put 1. 2/1. Some more examples to try in your notes. Practice writing ratios for the following word problems and simplify to lowest term. Do not change answers to mixed numbers. Ratios should be left in fraction form. Number 1. Out of the 301 seniors, 117 are boys. What is the ratio of boys to the total number of seniors? Number 2. It takes 11 cups of flour to make 3 loaves of bread. What is the ratio of cups of flour to loaves of bread? And number 3, a skyscraper that stands 530 feet tall casts a shadow that is 84 feet long. What is the ratio of the shadow to the height of the skyscraper? Please pause video until you have written a ratio for each example. So now that you have written your ratio for each example, let's look at them together. My number 1 says, out of 301 seniors, 117 are boys. What is the ratio of boys to the total number of seniors? Remember, we take what it is asking for first in our question part. So in our question, it is actually asking for boys first. So if I look at my boys, I have 117 boys. Now if I look at my seniors, I see that I have 301 seniors. So my ratio for number 1 would be 117/301. For number 2, it takes 11 cups of flour to make 3 loaves of bread. What is the ratio of cups of flour to loaves of bread? So I look in my question. It's asking me for flour first, and then my loaves of bread. So back in my informational part, I can look and it says it takes 11 cups of flour. So my top number is going to be 11. And for my loaves of bread, I would have 3. So my ratio would be 11/3. Looking at number 3. A skyscraper that stands 530 feet tall casts a shadow that is 84 feet long. What is the ratio of the shadow to the height of the skyscraper? So once again, I go to my question and I look and it wants to know the shadow first and then the height of the skyscraper. So my shadow is actually 84 feet long. And my height of my skyscraper is 530. Now looking at 84 and 530, I see that they are both even numbers. So I know I can simplify this ratio by dividing both numbers by 2, which would give me 84 divided by 2 to get 42 over 530 divided by 2 gives me 265. So your ratio in simplest form for number 3 is 42 over 265. Verbal cues that indicate a ratio relationship. 2 for each, for every. Have ready to turn in at the beginning of class. The co-ed soccer team has 4 times as many boys on it as it has girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. Reread this as 4 to 1. Finish the chart below. I'm going to do one more with you. So if I started out 4 to 1 equals 5 players, if I multiply 4 by 2, I get 8. And then if I do the same thing to my girls, multiply it by 2, I get 2. So the total number of players is 10. Just like when we was doing finding equivalent fractions, we would have to multiply or divide the top number and the bottom number by the same thing. Same thing goes for our ratios. Tape diagrams. A drawing that looks like a segment of tape, used to illustrate number relationships, also known as strip diagram, bar models, fraction strips, or length models. Example, suppose the ratio of the number of boys to the number of girls on the team is 3 to 2. Below is a tape diagram to represent this ratio. Each piece of the tape equals 1. So there's my 3 to 2. Let's try a tape diagram. Suppose that the ratio of the number of girls to the number of boys on the team is 5 to 3. Represent the ratio using a tape diagram. Pause video until you have created a tape diagram to represent the ratio above. So my answer, when I did my tape diagram, I would have 5 pieces of tape to represent my 5, and then 3 pieces of tape to represent my 3. 5 to 3. Have ready to turn in at the beginning of class. Suppose the ratio of the number of girls to the number of boys on the team is 2 to 7. Represent the ratio using a tape diagram. One more thing to have ready to turn in at the beginning of class. Come up with 2 examples of ratio relationships that are interesting to you. It can be anything that you can come up with that you can compare to get a ratio. And in summary, a ratio is an ordered pair of non-negative numbers which are not both 0. The ratio is written A colon B, A to B, or A over B to indicate the order of the numbers. The number A is the first and the number B is second. And the order of the numbers is important to the meaning of the ratio. Switching the numbers changes the relationship. The description of the ratio relationship tells us the correct order for the number in the ratio. Tape diagrams, a drawing that looks like a segment of tape used to illustrate number relationships, also known as a strip diagram, bar model, fraction strip, or length model. Hope you have a good rest of the evening, and I will see you tomorrow.